So, hello everybody. Let me introduce myself first. I'm Leah Verou. I work at W3C at Developer Relations. If you've ever heard my name before, and it wasn't from FrontTrends, it might have been due to one of my open source projects, Prism.js, which is a syntax highlighter that's being used in sites like Alistapart or Smashing Magazine or Brendan Ike's blog, or Dablet, which is a CSS playground, prefix-free, which is a library you can drop in and forget about prefixes in CSS, and a few others you can find at my GitHub profile. So like he said, I've spoken at every single FrontTrends so far, and FrontTrends 2010 was my first conference talk. So FrontTrends is a conference that means a lot to me. The first time I spoke at FrontTrends was about an overview of CSS3, and last year I spoke about transitions and animations. This year I'm speaking about border radius, so my talks seem to be getting more and more narrow every year. I'm hoping they also get more deep, but you'll be the judge of that. So when I started designing my talk, I wanted to create a creature that kind of represents what border radius is. No, I wasn't stoned or anything. So I came up with this kind of children's book character because I thought border radius would look like this kind of shy and cute creature that everybody thinks is not cool and nobody's interested in, but it ends up saving the day. That's how I see border radius. I think it's much more interesting than most developers give it credit for. So what most developers know of border radius is something that looks like this. You increase the value, and the rounding increases. The rounding, as you probably know, the rounding stands for the radius of a quarter circle at every corner. So you just decrease it and that changes. You already know that already. You probably know that browser support for it is pretty good, and that you don't really need to use prefixes for it anymore, although I've seen some really weird cases where people were using O prefixes or MS prefixes, even though these were never needed. But pretty much you all know that browser support for it is almost perfect as far as CSS3 features go. However, if border radius is that simple, why do we need 6 pages in the specification for it? Isn't it something that would probably be covered by 1 or 2? And that's exactly why border radius is not really that simple. The first complication is that you can define multiple radiuses per corner. So you can specify something like this, which defines, the first length defines the border radius for the top left and bottom right corner, and the second one for the other two. Or you can provide a third length, which applies to the bottom right corner, or a fourth one, let's say 400 pixels, that applies to the bottom left corner. Or you can even use shorthands, like assuming you wanted to have a 50 pixels radius in every corner except the bottom left one. It doesn't make sense to use a shorthand. It makes more sense to do something like this. Bottom left radius, 0, and specify 50 pixels only once here. It provides the same result, but you don't have to repeat values. The more you repeat values, the more you duplicate values in your code, the less dry it is, and the more times you have to change them, and the more chances for errors you are introducing. Here's a recap of what I just said. If you have 2 values, each one of those stands for 2 corners. If you have 3 values, the first one and the third one stands for their own corner, and the second one stands for both top right and bottom left. And if you have 4 values, each one defines 1 corner. And one easy way to remember them is that they go in clockwise order. Starting from the top left, every value defines a different corner in clockwise order. Here's a very typical case of using border radius to define the rounding of a button. It looks fine. What's wrong with it? We could even increase the border radius and increase the rounding a bit. It looks fine, right? No. Because you might change the font size. And then you would have to change the border radius too. Because the more the font size increases, the more it starts looking like a rectangle instead of a rounded rectangle. If instead you defined your border radius in ems, like 0.3 ems, then you could increase the font size, and the shape remained. I've done the same for the box shadow and the borders that are used here. That's why the other effects are scaling. It seems obvious, but I can't even count the number of cases where I've seen developers using pixels and things that shouldn't really use them. So this is where things start to get interesting. It's likely that most of you already knew what I just said, but this is where things are really starting to get interesting. So here I have a border radius of 900 pixels for the top left corner and 90 pixels for all other corners. So let me increase the value for the top left corner. Do you see what's happening? Even though I'm only adjusting the value for the top left corner, all the other roundings are changing. All the other, the border radius for all the other corners is also changing. Why does this happen? I didn't change that rounding. If you notice, I have 900 pixels here for all the other corners and 90 for all the other corners and 900 for the top left. The 900 is 10 times the rounding for the other corners. And since it doesn't fit, because my box here is not 990 pixels wide, so the border radius needs to be scaled down. And the way browsers choose to scale it down is by scaling all of the radii equally. So if you notice, the actual border radius here is 38 pixels. But here, it's 381, which is 10 times that. So even though it doesn't exactly apply the radius we defined, it scales it down so that the ratio between them is the same, so that you pretty much get the shape you were going for. So when I change this, I change the ratio between them. So the other radii have to change as well. Here's a quote from the spec about why that happens. It's worded in a bit more formal language than what I just said. When the sum of any two adjacent border radii exceeds the size of the border box, UAs must proportionally reduce the used values of all border radii until none of them overlap. If that doesn't make any sense to you, just remember what I just said. If it doesn't fit, it gets scaled down, and all of the radiuses get scaled down equally, so that the ratio remains the same. If you find maths easier to understand, then that's how it looks. And by the way, this equation is written with MathML, which I think is pretty cool, at least when you have simple equations like that. It enables you to do stuff like this in the browser, and it remains accessible, unlike LaTeX, which just generates images. So a recap of what we just learned in this section. We can have different radiuses per corner in clockwise order. Separate properties for every corner are available, like border top right radius. Other units besides pixels can be useful. And if the sum of two adjacent radiuses exceeds the length of their side, like your radiuses of the top two corners exceeds the width, for instance, they're reduced proportionally. So here's another example where I was trying to go for an ellipse. And I've specified 210 pixels radius, and as you can see, it's the maximum I can get. I can keep increasing it, but I won't get any higher radius because that's what fits. So how can I get an ellipse? That doesn't work. And it doesn't work because what we've showed so far creates circular curves. They're basically quarters of a circle. They're not quarters of an ellipse like what I wanted to do here. It will look like a circle if I reduce the width to something like this. That's a circle. But in any other width, it won't look like an ellipse at all. What can I do? There's a way to specify elliptical curves in border radius by using a slash. This is exactly equivalent to what I had before, but now I can change the two independently. The first one stands for the horizontal radius, and the second one stands for the vertical radius. So if I start increasing this, I get a quarter ellipse in the corners instead of a quarter circle. And you can see it here. You can see how it adjusts. And basically, since we don't have any straight edges, the ellipse at every corner fits the entire element. But this is still not exactly what we wanted. This covers one of our use cases, but not all of them. Think of this. If I increase the width, currently it's 540, but what if I increase it? This is not an ellipse anymore. It's some weird, ugly shape. It's not an ellipse. Can I do something that adjusts automatically so that I don't have to go back and do this? That's an ellipse, but then if I increase the width even more, it still won't work. So what can I do to have it work in every possible dimensions? It turns out I can use percentages. I can use 50% here and 50% here, which is basically what I wanted. I wanted a radius that's half of the width horizontally and half of the height vertically. So now, regardless of the dimensions I have, oops, caps lock. Now, regardless of the dimensions I have, it's still an ellipse. And I don't even need two 50% here. The horizontal and vertical one are the same value, so I can just have this. And this simple line creates an ellipse that works in every dimension. We can even use percentages to create other interesting shapes. For instance, semicircles or half ellipses. Think about it. Horizontally, what's half an ellipse? Horizontally, it has 50%, and vertically, it has 100% at the top two corners and 0 at the top bottom corners. And if I adjust the dimensions properly, it will look like half a circle. Otherwise, it will be half an ellipse. I can even create a quarter circle. If I adjust this, and I use the same, and of course I have to reduce the width, otherwise it looks weird, to something like this. So basically, here we have both horizontally and vertically 100%, and we don't want any rounding in all the other corners. We can even create interesting shapes like eggs, for instance. And you might be wondering, why do we need all these? Do we really need those when creating web apps? I'll show you later a few examples of weird border radiuses that are actually used in website elements. So let's try to create an egg. Horizontally, it's symmetrical, so it will have 50% radius horizontally. And vertically, we'll start from 50% and work our way. We want a higher vertical radius than for the top corners than the bottom corners. So let's start with something like this. First, this is for the top corners, this is for the bottom corners. We make sure that the sum of those is 100%. Otherwise, we'll start seeing straight segments. And we should reduce the width, because eggs are not really that shape. And it starts looking like an egg. Here is a recap of what I showed for when you have slashers. Basically, you can still provide 4 values. For 4 values for the horizontal radius, 4 values for the vertical radius, if you want. You usually don't need to provide a total of 8 values, but you can if your use case demands it. So if you provide 2 values for each dimension, they still apply to 2 corners. If you provide 3 values, the middle one defines 2 corners, and you don't really need to provide an equal number of values before and after the slash. They are expanded individually. So in this case, the 100 pixels here stands for both corners. And another interesting thing to note is that if you use 0 for either the horizontal or the vertical radius, the other one computes to 0 anyway. This could be 500 pixels or 5,000 pixels, and you'd still get the same result, because you can't have 50 on one edge or any number, or any positive number, and 0 on the other. How would it look? You have to use 0 for the other side as well. So a recap again, what we just learned. We can have different horizontal and vertical radiuses, or radii, both are correct. Percentages in border radius refer to the corresponding dimension. So if you use 50% horizontally, for instance, it refers to the width. If you use percentages for the vertical radius, it refers on the height. And if you just use one number, it refers on the width for the horizontal radius and the height for the vertical radius. Border radius can take up to 8 lengths if you want, but you don't really need to. And when either the vertical or the horizontal radius of a corner is 0, both compute to 0. Here's a very cool demo that I think summarizes why we need all this. It's not just intellectual masturbation of the CSS working group. It's something we actually need in real things. Here he used elliptical radii, Simurai, he's a genius. He used elliptical radii, he used percentages, he used different radii per corner, and the result is beautiful. I mean, this is a typical case, but he made so many other interesting shapes. This is a demo that isn't exactly practical. Like, you won't really need this in your web pages, but it's interesting to see the possibilities. And this is a website I designed for a family hotel. And I've used percentage-based border radius here to create the pebbles. Let me show them in bigger size. And I've used it with an inset box shadow and a texture to create this effect, and here in the search. And I'm sure you can think of many other examples as well. Here, I will answer your question that I'm sure you've had at some point. Why is border radius called border radius? Why isn't it called corner radius? Isn't that what it does? Well, yes, everybody in the CSS working group admits these days that it wasn't a very good idea to name it border radius instead of corner radius and something like that. But there was a reasoning. And the reasoning was that when you specify border radius 40 pixels and you have a border, what's rounded to 40 pixels is the border box. It's not the padding box. If I show you here, this is what gets rounded to 40 pixels. The inner radius is smaller, and it's smaller by the width of the border you have. If I increase this to 30 pixels, it gets even smaller. And if I increase this to 40 pixels or more, you'll stop having a rounding in there. I can keep increasing the border, and you don't get any inner rounding. Sorry. In the spec, this is phrased as the padding edge inner border radius is the outer border radius minus the corresponding border thickness. In the case where this results in a negative value, the inner radius is 0. And here it is in maths, if that's easier to understand. But basically, in simple English, it's what I said. The inner radius is the outer radius minus the border. And this also applies when you have different thicknesses. For instance, here, you have a different border top and a different border right. And you have just one border radius that's 40 pixels. What that means is that even though this is a circle of a radius of 40 pixels, the inner radius is not. The inner radius is an ellipse, and you get an elliptical curve. And since you have different borders on the other edge, you still get 40 pixels on the outer edge, and you get a different, inner radius. The question is, what happens if you don't want the elliptical curve here? When you don't want this, when you want this to be a circle and you don't care about the outer one, you would have to special case border radius and define a different radius for top right, where you would compensate for the extra thickness by using a bigger horizontal radius. So you would do 50 pixels, 40 pixels, 50 pixels horizontally and 40 pixels vertically. One important thing to note is that when you're using the longhand, there's no slash. This is invalid. And I can't even count the number of times that this has bit me. Like, I entered a slash in the longhand, and it's invalid CSS, so it didn't work. And I was like, why doesn't it work? You only use a slash when you're specifying different horizontal and vertical radii in border radius. When you're using the longhands, like border top right radius, they're white space separated. There's no slash. So here we've done what we wanted, and let's look at the big picture, literally. And that's how it looks. I would argue it looks better, but that's up to you. At least now you know how to do it. So what we just learned, border radius rounds the outer border edge. The inner border radius will be smaller, and that's why it's called border radius. Even with a circular radius, like 40 pixels, the inner radius might be elliptical if you have different border widths. And if your borders have different colors, the transition will be abrupt and diagonal. Let me show that. So let's remove this to have simpler code. And let me show you how it would look if I had a different color here. The transition doesn't happen through a gradient or anything. It's just abrupt and diagonal, and it only depends on the thicknesses of the borders. It doesn't depend on the border radius. Like, you can increase this all you want, and you'll still get the same transition. You can even do things like this, although it's probably pretty pointless, but I thought it was interesting. So you can increase this a lot, and you can use 50% here, and you can even use different colors, like border color, or red and green. Pretty pointless, but I thought it was interesting. So what about shadows and outlines? We've already talked about the interaction of border radius and borders, but what about other effects? Box shadows work pretty much the way you expect. Their rounding is the same as the border radius, unless you're using a spread radius to make them bigger or smaller. If I make the shadow 10 pixels bigger, its radius will also be 10 pixels bigger. And if I make it 10 pixels smaller, even though you can't see it, but now you can, its radius will be 10 pixels smaller. So if I make it 20 pixels smaller, there'll be no radius on the shadow. Unlike shadows, outlines don't have any rounding. So one outline. So they look pretty bad when you have border radius, especially when you have big border radius. So what can you do for that? You can emulate outlines with a box shadow, and it even has the same property of outlines that they don't affect layout. So you can do something like this: 0 offsets, 0 blur, and 10 pixels spread radius. So you can manage to create the same effect with shadows. And you can even make them inset if you want them to be designed in the inside of the element instead of the outside. So what we just learned again, box shadow does follow the curves of border radius. Box shadow spread adds to the border radius, or removes if it's negative. Outline is always rectangular. There is a Mozilla extension that's called Moz Outline Radius that allows you to round outlines, but it doesn't follow your border radius automatically. You have to round it separately and adjust it every time you change the border radius. And also, it's Mozilla specific. It's not a standard and doesn't work in any other browser. So emulating them with box shadows is better. You can emulate rounded outlines with box shadow with no offsets, no blur, and a positive spread radius. Another interesting fact is border radius is animatable. You can do animations with border radius. It seems obvious, but you don't really see many effects with that. And you can create many interesting effects with it. For instance, things like that. And another interesting thing, like, why is border radius different from all the fallbacks that use background images to emulate rounded corners? It's not the same, not only because of borders and box shadows and all that follow this effect, but also box shadow affects the hit testing area. So if you have overflow hidden, see, I can hover here and nothing happens. I have to hover over the actual area of the element. So border radius is animatable. We can animate between any two radiuses, and it affects the hit testing area. So you might not be impressed so far, but there are many cool things that are coming to border radius in backgrounds and borders level 4. And the coolest of them is called border corner shape. You'll be able to use, assuming that actually doesn't get removed from the draft, because it's currently in a very early draft, so anything could happen. Name could change, the functionality could change, anything. But it's currently in the editor's draft, so if it remains, you'll be able to use border radius to define the size of corners, for instance, that, and you'll be able to have many different corner effects. The default that we have now is curve, but you'll also have bevel, scoop that does this inner border radius effect, and notch that cuts out rectangular areas from the corners. And they're useful for many more things that they seem for. Like, for instance, for bevel, you can do all kinds of shapes. You can do trapezoids like this. Oh, you can do rhombuses, diamonds like this. You can do trapezoids by giving it 100 pixels horizontally and this way. And you can even increase this. And you can even have triangles that we go to huge lengths to do triangles today. Or with notch, you could have things like crosses and things like that. I think it will be amazing once it gets implemented. But until then, what can you do? For bevel and scoop, there is a way to do a similar effect with CSS gradients. And you can even adjust this quite easily to adjust the size of the corner that's getting cut off. And you can even have different sizes per corner. You can do something similar with radial gradients. You don't need to memorize the code. My slides are online, by the way. You can do something similar with radial gradients. Yes, having 4 background images is not ideal, but at least it works. And the way they work is you have every single gradient is a quarter of your element. That's why they have 50% background size. Like if I change this to green, for instance, you can see what's happening there with every gradient. Or if I make this, I don't know, black, you can see there what's happening there. And there's an abrupt change because this color stop position is after this one. So I'm about to finish, and wow, I didn't even go over time. That's a first. So if you feel you've just forgotten everything, here are a few resources that might help you. Webplatform.org is, how many of you have heard about the Webplatform? Oh, great, many hands. So it's a documentation effort by W3C and many other companies, all the big players of the web, Google, Microsoft, Mozilla, Opera, Intel, all of them, so that we create a vendor-neutral documentation effort, and the community will be able to contribute as well. It's a wiki, so you can edit everything. But unlike other websites that developers currently have, all the companies are contributing to it, so it's not controlled by any company, really. All the other websites are controlled by a single company. And by the way, if you want, I have web platform stickers with me, so just find me in one of the breaks and get one. And this is a link to the spec. So before we go into questions, assuming we have time for questions, which we probably don't, the top question I usually get when I give a talk is, how did you make the slides? So in case that's what you were about to ask, here's the answer. It was, yes, it's in the browser. The Slideshow Framework is something I built for my first front trends talk, and I keep adding stuff to it. It's on GitHub. The illustrations are built with SVG, not with border radius like somebody thought, because otherwise I wouldn't be able to do many things that I did here. Mr. Border Radius's face is animated with smile. And the equations displayed, two of them, two equations were displayed. They were built with MathML, and I'm using a CSS fallback for Chrome. So that's about it. Thank you very much. These are my slides on that URL.
Thank you, Leah.
Do you have time for questions?
I think we can take one, maybe. Is there anybody who... OK, let's take this one.
Hi. How about box sizing property? How does it affect border radius? Does it affect it or no?
Well, border radius always rounds the border box anyway, so regardless of your box sizing value, it doesn't really affect it. Box sizing might affect your dimensions, so if you have border radius in percentages, it will be affected because the dimensions change. Or if you have border radius that needs to be scaled down, that can also be affected. But border radius is not directly affected by that. It might be affected because the dimensions are changing.
OK, thank you.
Thank you.
Guys, we are serving